Hello. Today we're going to be talking about applications of quadratics, specifically with the vertical motion model. So you can see the vertical motion model down here is h of t equals negative 16t squared plus v naught t plus h naught. Now h of t, this represents the height of an object at a specific time. Time is your independent variable. That's your x value. That's where you see t. T is standing for time in this one. Negative 16 is just the force of gravity. So that part's never going to change. What is going to change depending on the situation is two different things. V naught, it looks like V sub 0. This stands for your initial velocity. So something in your word problem is going to say the initial velocity was 12 feet per second, or it'll say it was kicked at a speed of this amount. So an initial velocity represents your speed. The other thing you might see is an object might be dropped. If in your word problem the object is dropped, that means the initial velocity is 0. So you could plug in 0 for that one. Now the other thing we're going to have to plug in here is your initial height. So h naught or h sub 0, this is your initial height. So it'll say like it was hit from a height of 4 feet or something like that. Again, if it starts on the ground, that means your initial height is 0. So what we're going to do is we're going to look at a graph and we're going to try to analyze this graph and write an equation and everything, and then we'll go through and do a couple more examples. So the first one is we're going to launch a basketball at the hoop. So we're going to shoot a basketball and Frank makes a basket. The equation given to us is here. So h of x is the height of the basketball in feet and x is the time. So this is our vertical motion model. So the initial height the ball was thrown from is kind of taken from above our vertical motion model setup. So as a reminder, here's our vertical motion model where oops, our initial velocity is in front of the t, and the initial height is just the constant that's there. So looking at this, whatever is in the spot of the constant is the initial height. So in this case, the initial height is going to be 6 feet. And therefore, the initial velocity normally is coming from whatever's in front of the linear term, or just the t or just the x, which in this case here is going to be 37 feet per second. Once we have that initial setup of plugging in the velocity and plugging in the height, then we can analyze this quadratic using the stuff that we've learned previously from this chapter. So what we're going to do is we're going to take a look at the graph of this. So this is the graph of that basketball. Whenever you see something asking for the highest height, what that is asking for is it's looking for some part of the vertex. So in your vertex, you have your x coordinate and your y coordinate. So in this word problem, the x coordinate is the time, the y is the height. So let's take a look at this vertex over here. So 1.156 is the time when the ball gets to the highest point, and the y value is the height itself. So this one is asking specifically what is the highest height. This is asking for our y coordinate of our vertex. So the highest this basketball gets is going to be 27.391 feet in the air. So when does the basketball actually reach that height? Well, that is also going to be looking at your vertex because it's talking about the highest height, but this is asking for your when value. So this is asking for your x value of your vertex. And on our graph, we can look at that and say 1.156 seconds. If our graph was not given to us, let's make a note off to the side here. If our graph was not given to us, you need to do your negative b over 2a to find the x value, and then plug x in to find your y value. That would help us answer then questions about the maximum height. So then we're going to have a different type of question. When does the basketball hit the ground? So visually looking at our graph, hitting the ground is when the basketball gets back down to a height of 0. So this, anytime you see something about hitting the ground, this is looking for your x-intercept. And so on the graph, what we can do is we can just pull that x value at 2.465 seconds. But again, we're not always going to be given the graph. So if we're not given a graph, what we need to do is we need to solve when your height is 0. So you can use methods like the quadratic formula and factoring, whichever one seems easier with the quadratic you're given. Honestly, we're going to rely more heavily on the quadratic formula because these ones are not necessarily going to factor too nicely. Okay, let's try another example, but this time we're not given the equation and we're not given the graph. So we have a rock being dropped off a bridge that is 30 feet above the river. So as a reminder, our vertical motion model is h of t equals negative 16t squared plus v naught t plus h naught. So we need to figure out our initial velocity and our initial height and plug those in. So our equation is going to look like h of t equals negative 16t squared plus our initial velocity. So in this problem, since our rock is dropped, that means our initial velocity is going to be 0. We also need to find our initial height. This 30 feet above our river is telling us our initial height. So our initial height here is 30. So we're going to go ahead and plug in 30 there. And we're going to simplify this because that middle term, anytime you multiply by a 0, it just is the same thing as it not being there. So our equation here is h of t equals negative 16t squared plus 30. So for part B, how long will it take for the rock to hit the water? So this is telling us when the rock lands back here in the water, that means my height is 0. So I'm going to plug in 0 for my ending height. And I'm going to solve that equation. Now we can use many different things. You can use your quadratic formula if you wanted to. You could try factoring. Factoring is not going to work for this one. I'm going to say I notice that there's a squared term and no just normal term with a x or a t. So I'm going to solve by using square roots. So I'm going to move the 30 to the other side. I get negative 30 equals negative 16t squared. I'm going to divide by negative 16. So I get t squared equals 30 over 16. The negative over the negative makes it a positive. And I'm going to go ahead and square root both sides. And I'm going to go ahead and type this in on my calculator. So I would get positive and negative 1.37 seconds. But the negative one doesn't really make sense in this situation. So I only want my positive answer, not the negative one on the other side of my x-axis, because I can't go back in time. So it's going to be 1.37 seconds for this one. So let's go ahead and try another one. We have now a baton twirler for example 3. She's going to toss that baton in the air, and it leaves her hand at 6 feet above the ground and has an initial velocity of 45 feet per second. So we are looking at something visually that looks like this. That's what our graph would look like. Our equation, again, the generic one is h of t equals negative t squared plus v naught t plus h naught. So our initial velocity is given to us in at 45 feet per second. So we're going to plug in 45 for v naught. The initial height is given to us in the 6 feet above the ground, so we're going to plug that in. That would be our vertical motion model. Part B is asking, when does the baton reach its maximum height? So when you see something like this, again, we should look at our graph and think of our maximum height here. This is talking about the vertex. And since it's when, it's asking for the x value of the vertex. Now, if we had everything labeled on our graph, we would just be able to pull that off. But we don't have everything on our graph, so we actually have to find the vertex. So what we're going to do is we're going to go back and use x equals negative b over 2a to figure out what that x value would be. So looking at our equation up above, we have a, b, and c given to us because we were able to fill in our equation. So we're going to do negative b, which is negative 45, over 2 times a, which is negative 16. So we're going to do negative 45 over negative 32, and we can type that in on our calculator to get a decimal answer. So when does the baton twirler reach, the baton reaches maximum height? It's going to be at 1.41 seconds because that is the x value of their vertex. So for part C, how high does the baton go? This is asking for your y value of your vertex. So the maximum height is here. The y value here is actually going to tell us how high up it is. So what we're going to do is we're going to take the x value of our vertex and we're going to plug it in for our time. 1.41 is going to now get plugged in. I'll show you on your equation up here. Everywhere you see that time. So it's negative 16 times 1.41 squared plus 45 times 1.41 plus 6. You can type this in on your calculator, and you can type it all in at the same time and hit enter. And if you do that, you're going to get a maximum height of 37.64 feet. So that would be your y coordinate of your vertex, and that is the maximum height the baton will reach. We have one more part here, though. I'm going to zoom out so we can see that graph still. How long does it take for the baton to drop to the ground if the baton twirler misses the baton? That is looking for this part right here, which is your x-intercept. So it's asking when will it hit the ground? That's your x-intercepts. What that means is your height is going to be 0. So we're going to plug in 0 for our ending height. And we are trying to find then the time. So in order to find that time, what we're going to do is we're going to solve this equation using our quadratic formula. Factoring is not going to work so nicely. We're going to use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and we're going to get a decimal approximation. So we're going to do x equals negative b, which ends up being negative 45, plus or minus the square root of b squared minus 4ac all over 2a. And so what we can do here is we can type this part in on our calculator. We're going to get 2,409 if we type that all in without the square root. So then to calculate your total answer, you can type in on your calculator what I've written now below. These two things right here, notice it's negative 45 plus and minus the square root of 2,409 in parentheses all over 32. You get two answers, negative 0.13 and 2.94. The negative one does not make sense, so it's 2.94 seconds. Thank you very much. Have a great day.